Okay, welcome everyone. It's 3 o'clock today, and I think we will wait another minute before we formally kick off the meeting. We have the CEO of Realfiction, Claes Dyrholm, and the CFO, Torben Ockels, with us on the call today. A call that we are hosting due to the fact that the company is raising new financing in a rights issue that is currently in the market. We have an agenda where Claes and Torben will go through a corporate company presentation, and afterwards we will follow up with the Q&A session. Those of you that have posted questions to us beforehand, we will try to answer as many as possible of them, and I will try to moderate the forum in the Q&A and also ask the questions to Claes and Torben. If you would like to ask another question or add questions throughout the presentation, please do so in the Q&A tab, which should pop up on the bottom of your screen. If you have the Swedish version, of course, that's frågor och svar, or the Q&A if you have the English version. So please post any questions in that window, and I will read them out towards the end of the presentation. So with that, I think we have most of the people that have signed up to the meeting online right now. So please, Claes and Torben, take it away from here.
Thank you very much, Per. So welcome, and thank you for your time. Torben will join us for the Q&A session. I'll be doing the presentation beforehand. So Realfiction is a company, as you may know, founded back in 2008. We have our operational headquarters in Copenhagen, Denmark, and we have a subdivision with engineers mainly in Taipei, Taiwan. We consider ourselves as pioneers within the 3D display industry, and when we refer to our legacy products, we mean those type of products you see here. We have designed and developed a long list of products. We are still on a minor scale, though, selling and renting out these displays, but we are shifting our focus. Because quite a few years ago, we initiated a development project called Directional Pixel Technology, which is today our main focus, and all I'm going to be talking about today. With this project, we started the ambition of redefining multi-view and multi-user 3D displays. That's a rather big and bold ambition, of course, especially because we want to do so on many different scales and applications and industries. Anything from home entertainment, in-car entertainment experiences, but also on a larger scale and more exhibition or entertainment scale, venue scale, eventually. So it's a bold vision, but nonetheless, something that we have taken on as a technical challenge. What we've invented is a technology we call Directional Pixel Technology, and referred to often as just DPT for short. Now, DPT has a unique list of a unique set of features. So we can do glasses-free 3D, and we can do this for multiple people. What's unique here is we can do it with no resolution loss. The currently dominating 3D display or glasses-free solution is what is referred to as a lenticular display, which is a display overlain by a lens array structure, typically laminated onto the display, set of micro lenses or optics that creates a 3D image. That will always sacrifice resolution. Our technology is completely different, and one of the main takeaways here is we never sacrifice resolution. That's also one of the big benefits that the industry sees in our technology. On top of that, we can create what is referred to as look-around 3D for multiple users at a time. This is also very unique. When we say look-around 3D, it means that you can look around a 3D object, seeing it from different perspectives as you move your head. And typically, that's only possible for one user on a current glasses-free 3D display. We can enable that for multiple users at a time. And that technically means that we have to be able to send different 3D images to each person. So that's rather technically advanced. We can then do a set of 2D features. We can do dual view, which is typically referred to in-car situations where the driver wants to see one thing on the screen while the passenger or passengers see something completely different on the same screen. So a multi-view scenario could be a 2D a dual view scenario where two different types of content are seen on the same screen depending on from where you see it. Now, beyond dual is the multi-view, where this number can be more than two different types of content. And with DPT, we can reach a rather high number of different images. And this can also be used at a very large scale, where you see today big screen LED displays creating a 3D illusion, technically referred to as a forced perspective. And I just want to briefly touch upon that, because what is a forced perspective illusion? Well, as in this case, it's basically a 2D image creating a feeling of 3D when seen from a certain point of view. In this case, it's a charcoal drawing on a pavement, creating an illusion of a cavity in the road. But it only really sort of seems 3D when you see it from this specific point of view, since it's a 2D drawing. This is used on big displays, but again, limited to a certain area or point of view. With DPT, we can enhance that because you can then shift your position, and then because we can shoot different images in different directions, you see a new 3D perspective, and therefore the illusion would still work. And this can be used both in advertising, but certainly also in future entertainment venues, and I'll come back to that. And then the last thing we call e-privacy is basically what we technically think is the least interesting one, because it's more or less a multi-view scenario where we switch off some of the images. So from certain angles or for some persons, the screen can go black depending on the use case. Now, because our technology is unique, we can create what is called a dynamically or movable eyebox, a dynamic eyebox, meaning that we can track the face of a viewer. If there's a camera in a laptop, for example, we can then make this view zone, which could be the only place where you can see the image, we can make that zone follow the face of the viewer. If you combine that with a feature like face recognition, which you may know from Apple devices and so forth, we can even then add a unique layer of security where only a certain person can see certain types of information on the screen. Now, our business model is based on technology licensing. So this more or less means that we are not a manufacturer, and this is rather important. We do not intend to manufacture or produce the end product. Instead, we offer our core technology to manufacturers based on licensing fees. So that's the business model that we're following, and this means that we are targeting the huge manufacturers of displays. And this means that our revenue should be coming in the end when products are in manufacturing from per unit licensing. So could be a fixed fee per unit that's produced, for example, but will initially also come from upfront and milestone payments, which is typically referred to as NRE fees, because often a project or new product is started by a phase where you target our technology into a specific product, could be a certain size, could be a certain feature set. And in that phase, which is called the NRE phase, there are certain upfront milestone payments, and then hopefully leading into mass production and giving us per unit licensing fees later on. Thanks to our technology partners, we are also capable of manufacturing proof of concept devices, for example, or co-developing POC units that can give us revenue as well. We have a management team of dedicated and very experienced persons. With me today, I have Torben Walkers, very experienced accounting and many other areas. Richard is heading our Taiwan office, which is slowly growing, and I'll come back to that later on. And then Steen has founded a lot of our IP ideas and is heading sort of the core technology as well. But we are a small company with a rather small team, and this is important to understand. And therefore, our business model is also based on collaboration partnerships. Therefore, I want to spend some time on addressing a few of those. On the IP and innovation side, we are collaborating with large institutes like Fraunhofer, IMEC, Hong Kong University. But then we have a list of commercial partners as well. The first one we announced was Amtran, and they have been a partner of ours for many years now. And they have been manufacturing some of our legacy products for a long time as well, and are a shareholder as well. Now, Amtran is maybe not the one that's mentioned more lately. And yeah, to understand why, I want to show their part in the industry supply chain. So if you see their main vendors, so where they buy most from, is called panel makers. So these companies are the companies, or some of the companies, creating the actual display panels. So the component that creates the image, that directly shows the image in a display. So Amtran is not a panel maker. They cannot create the actual image-based components. They buy that from panel makers like LG, Samsung, and many others. Then they buy other components like semiconductors. And then what they do is they manufacture the end product. And typically they slap another brand on the product because they're very good at quality and pricing and sourcing. So they can manufacture often better and cheaper products than the brands themselves. So often the end product will be an LG TV, a Samsung monitor, an Apple product, whatever. But the important thing to understand is Amtran cannot do the actual panel. And since DPT is a technology that needs to incorporate on the panel side, these guys, and there are more, of course, are the ones we target at the moment, first off, because the panel manufacturers are those that need to integrate our technology. Then as soon as we have this panel component, Amtran becomes again a very important partner because they are so good at what they do, creating the final products. The first panel manufacturer that we have announced a collaboration with is Goworld. Goworld is, they have several LCD panel manufacturing facilities. Goworld is not Samsung, it's not LG, so it's not a huge manufacturer. And this means that it's easier for us to talk with the top management. And that was key for us because a panel manufacturer is typically very sort of conservative. They don't invest a lot in new technologies until there's a huge and visible market. So we needed to find someone that were hungry for new business, but also willing to discuss the creative innovation part. And this is Goworld. Therefore, we were able to make a deal with Goworld where they invest. They're not paying us any money, but instead they invest a lot of resources and capacity for free into this partnership in order to become or to be able to manufacture DPT-enabled components. So that's where they are very important. Another thing that makes Goworld very interesting is the customer list. So especially the part up here called automotive, This segment of their customers actually represents more than half of their revenue stream. So Goworld is a well-known and established tier 2 manufacturer for the automotive industry, and their products are already well-known and integrated into many car brands. They have a long list of so-called tier 1s as their customers, so they are an established part of the supply chain for automotive. So that's another reason why Goworld was a good choice for us. The last commercial partner I want to mention is PlayNitride. PlayNitride is a world leader within micro LED. Micro LED becoming an increasingly interesting display technology for the future, because it has a set of features that are very interesting once it matures in the manufacturing side. So micro LED is currently becoming more and more available either in high-end TVs, on wristwatches, and in automotive also becoming available there. But it still needs its actually sort of breakthrough in the high volume markets like normal TVs or monitors you see at home. And that's why we sometimes refer to as a coming important technology, not because it's not ready available, but only because it's only currently available in a very small market share as for now. But PlayNitride is certainly a very interesting company and a leader in the development of technology, and therefore it was great to collaborate with them. And together with them, earlier this year, we unveiled the world's first glasses-free 3D micro LED display, and that was a really great experience for both them and us, because that caused a lot of attention on a few exhibitions, also from the major corporations and panel manufacturers, led to a lot of interesting, currently also open dialogues between us and big panel manufacturers. So that was a great collaboration. The sample we showed was rather small because we took one of their panel modules. An LED display is typically built of several modules that are stitched together. We took one module to show that we can show, or to demonstrate that we can show 3D on micro LED, because that's up till now something that has not really been achieved with normal lenticular technology. And this is because LED displays, and therefore also micro LED displays, are really hot on the surface of the LED. They dissipate quite a lot of heat on the surface, and the display needs to get rid of that heat. Now, a typical lenticular display would glue or laminate this array of micro objects directly on top of the display surface. And you can maybe imagine that closing that surface heat within a glued plastic layer is not really a good idea. And that's why this has been a problem typically. We can, when I explain in a moment our technology, we can enclose it completely if we want to and laminate our technology on top, but we can also leave an air gap. This is very important for LED. Now, when we showed these displays, and why are we not showing videos? It's also another good question. Well, because in order to see 3D with our technology, we need to have a camera detecting the left and the right eye. And then we show different images to the left and to the right eye. So this is not something that we can record with a 2D camera and show on a 2D video like this display. So it wouldn't really make sense. But when you see it live, the display will track your eyes and show you a 3D image, because each eye sees slightly different images. We had a lot of good reactions, but it was also obvious that there were a few what we call image imperfections. So one visible imperfection was we had some vertical lines. You could see sort of small vertical lines in the image, which of course you don't want to see on a display. That's mainly caused by a mismatch between the display size and resolution and our SLM or spatial light modulators design, which was originally designed for another display. This is something that we are addressing in the new iteration we're doing, but also something that will need to be adapted for some displays, for some versions per product base. Is those things have to match, and yeah, PlayNitride changed the display we were to use a couple of times, so it was not really possible to make those two things align in the end. To understand how our technology works and what is a spatial light modulator, I typically use this image. We take a display panel, and this can be an LCD panel, could be an OLED, LED or micro LED, doesn't really matter. We then drive this display using our unique algorithms and driving algorithms. They do different things. One thing is they drive the display faster than you normally do at a higher frame rate. And then they do what is referred to as time multiplexing, and a lot of other things, of course, but to keep it simple. And then on top of the display, we add this item we call a spatial light modulator. So a light modulator is an electronic object that can modulate the direction of light. So steer, in our case, steer a unique light pattern in a very unique direction, and then switch that electronically extremely fast. Technically, it's basically an LCD panel, and this is why we need the panel manufacturer like Goworld to manufacture it for us. But it's not the same LCD panel that you would use for an LCD TV. It's a unique design, it's a unique driving principle, so it's completely different than the LCD panel that you would use for a TV, and it's also much cheaper in production because it does not have to create the image. The image is created by the actual display panel in the back, and then our spatial light modulator, or the SLM, mainly functions or purely functions as a directional provider. So it makes the image directional. And again, since we don't use physical optics, we don't have a sheet of lenticular micro optics or anything, we don't have any physical lens barrier, then we don't have to sacrifice resolution from the display panel. We can show the full resolution no matter how many positions you want to see different images. So that's totally unique. And we can very smoothly adapt the position of each image depending on, in some cases, we use eye tracking, as I said, depending on the position of a viewer's head, for example, we can smoothly follow the position of the eye or the head, and thereby get rid of some of the artifacts that are known from lenticular displays, where you see bad zones where you are in the middle of two fixed zones, and then you see some blurring and some other artifacts. So we don't have that as well. And finally, but not least, we have a much wider viewing angle. So our displays can eventually be seen from a much steeper angle than those of a lenticular-based 3D display. Some of the main competitor problems, there are glasses-free 3D displays out there, and currently they are becoming more, which is a good sign of the 3D progression in the industry. But most of them are single user based, so only one user per time can see the image. This is a big limitation, of course, in terms of use cases. There are a couple, and I'll touch upon that in a later slide. A couple of them do show multi-user 3D, but with other limitations as well. Almost any currently known 3D display is lenticular based. So with the resolution trade-off, with the lenticular sheets on top, I'm not saying that's a bad technology. I'm just saying that that technology comes with a lot of limitations, for sure. Always with a resolution loss, typically with a single user experience, and often or currently always with a high complexity and cost in manufacturing. This is because when you align or laminate a lenticular on top of the display, this has to happen very precisely because each micro optic has to specifically align with some of the sub-pixels from the display. And if that's wrong, then you have a glued display that you have to throw out in the garbage bin. You cannot really redo it. So that means that the final products are currently way too expensive. With our technology, we can electronically calibrate. We don't have to laminate precisely because there are no physical lenses. So that's also a huge benefit. 3D can be seen in different ways. So 3D can be seen where everybody sees the same 3D, like in the movie cinema. We can do that. And that's typically what you see if you see a multi-user 3D display today. But as said earlier, we can also do 3D multi-view where every person see an individual 3D perspective and maybe even a real-time animated 3D perspective. This can be 2D as well, can be different images, always with no resolution loss and with very low or no noticeable crosstalk. We have had our first DPT revenue. So we announced almost a year ago the first project. And just because there has been several questions about it, and we understand the curiosity, of course, and we are sorry we cannot share more, but we are under heavy NDA because it's still a secret project and ongoing project. What we can say, it is not an automotive dual view product. It's not a 3D project. It's a huge project within the entertainment industry and in this sort of area of multi-view, 2D multi-views. And this is why I highlighted this one. This image is not from the project. I just want to highlight that. It's just for illustration purposes. But it's a project that requires quite a few different images to be seen from different positions. That's what we can say. And we delivered successfully a POC that enabled that. And whether or not we are part of the final solution remains to be seen. We don't know yet. If we compare ourselves to some of the industry competitors, the first three on this list are 3D competitors. So Layer, Ink, Sony, Looking Glass. Layer Ink has been very successful over the last few years at doing what we do in terms of licensing. So they have licensed their lenticular technology to many brands. So they are also the technology of the Samsung Odyssey monitor, for example, and many other displays. They have a traditional lenticular display, and I think the best one out there currently, but always limited to a single user. So that's a big limitation, also recognized by the panel makers we speak to. Sony is doing more or less the same, but with their own sort of take on it. Looking Glass Factory is interesting because they are one of the only ones doing a look around 3D for multiple users. So that's rather interesting, but they do so with a heavy resolution loss. So they are creating many different perspective views from the content, and they have to subdivide the resolution by 16 or sometimes up to 32 times, resulting in a very poor perceived resolution and other artifacts like very limited depth as well. And very high cost, not forgetting. On the 2D multi-view side, we have JDI and Sharp as the main competitors. And if we see a comparison chart here, trying to compare more directly, we will see Realfiction in the first column here, Layer, Sony, and so forth. The first row is called multi-user 3D look around. So who can do 3D for multiple people where you can look around an object? Well, only Looking Glass in this list is a capable of doing that, but as I said, with an extreme resolution loss. We have no resolution loss. And then who can do 2D multi-view? Well, JDI and Sharp, but again, they lose resolution. Currently, we can see nobody else in the market that can freely switch between 3D, 2D, 2D multi-view, privacy, etc. We can do that with DPT. And we can see nobody else capable of being compatible with LED, micro LED, and even DLP projection, which we can do with DPT as well. Now, we also, of course, have to list something that we cannot do, which they can do, which is what we call low refresh rate. Now, I was saying a bit earlier that some of the things we do on the display side is we drive it a little bit faster than you would normally do. So this is, you could call it a limitation on our side. We cannot just take the lowest and cheapest display out there capable of running, let's say, 60 Hertz and use that. We cannot. But when we speak to the industry, they say, but high refresh rate is not a problem. And so, no, it's not a problem. And there is on many or the major technologies, OLED, micro LED, DLP, LED, there are no limitations on speed. So you can go insanely fast. So it's not really a limitation either. LCD displays have a certain speed limit, but not a speed limit that's beyond our capabilities. So we start at about 240 Hertz and then go up from there. And 240 Hertz is also capable on LCD displays. So just saying that this is where the others can do something we cannot is run the display in a slower rate. But there's no obvious benefit there, just stating it to be clear. DPT lies on top of an expanding patent portfolio. So we are running and constantly expanding our patent portfolio. We have also secured exclusive rights to some certain patents from Hong Kong University of Science and Technology, which are about the FLC high-speed crystals, which we mentioned in the Q2 report as well. So the overall conclusion, I want to leave as much room for Q&A as possible. The overall conclusion here is that DPT offers a revolutionary 3D, but also 2D multi-view experience. We're able to do that on all the major display technologies and even the ones coming. So it's a future-proof technology that also goes hand in hand with the content developments we see happening both on the real-time content generation front, but also on the AI scene. And it's a cost-effective and scalable solution. I forgot to mention that our SLM can also be manufactured as a module that you can stitch together, just like an LED smaller module are stitched together with other small modules to create a very large screen. The same can be said about our SLM. We can design the SLM as a modular component that can be stitched together. So that's important. So much for the overall presentation, Per, and let's deep dive into some questions.
Certainly, Claes, and thanks for the presentation. I will try to do my best to sort the questions into categories, and some of the questions I have received, I believe, have been answered by your presentation. But if we start by going into perhaps one of the key components in the DPT technology, the SLM, or the spatial light modulator, there seems to be a lot of interest on the new version of the SLM, or the upgraded SLM that gets rid of the artifacts that you mentioned, the vertical lines and so on. Can you just elaborate a bit on the need for that upgraded SLM in order for you to pursue additional licensing deals or NREs, or deep dive into your customer dialogues that you have. Is it a need, or is it a nice to have or a need to have that new SLM?
Good question. No, in some cases, it's not a need. So we are in concrete project dialogues where the current SLM is involved in the considerations. But it is a need for some cases and for some sizes, and specifically also for some resolutions. It is a need to do a new design. We then combine the new design with the integration of the ferroelectric crystals, the FLC component. And we do this to further elaborate on the features we can use this SLM for. And this basically comes down to speed, because the faster we can run the SLM, the more different images in different positions we can show. Because time multiplexing relies on speed. The faster we can run the display, but specifically also the SLM, the faster we can control specific directions and multiple different image pairs. So as we are doing an iteration on the SLM, we feel it was very important to also fully free or set free the capacity of DPT with the complete feature set. And this is also based on feedback we have from the big industry players, is they recognize how far we have come with the project with PlayNitride. Of course, they see these minor image imperfections, and they believe we can solve that, even though it's important that we show we can. But they also say that they are eagerly awaiting the sort of proof that we can do the full Monty, the multiple users seeing, look around 3D, for example. And in order to do that, we need to include the FLC component. So that's why we're doing that as well. But back to your original question, no, for some cases and in some examples, we do not need the new one. So it does depend on the project, and we are in project dialogues now, where the current SLM could certainly also play a role, and therefore also play a role this year. Yes.
Okay, great. And continuing on that topic, the development of the new SLM, is that something that you do by yourself? And I think you in part answer that question saying with the reference to Goworld, but do you do that in combination with partners, and who carries the cost for that development?
Of course, we spent some time doing the new design, which we've already done, and this is already in production. So it's not like it's a very long timeline. But the actual cost on the development side and manufacturing side is not a big cost on our side. So that's one of the huge benefits of having commercial collaboration partners, which maybe do not pay us a lot of money up front, but invests in our future collaboration by allowing their engineers and their manufacturing sites to spend a lot of time on enabling this technology together with us.
Okay. Two more questions relating to SLM. When do you think you can release the new SLM approximately, and how much time do you estimate is needed to implement the new version of your SLM?
We have an internal timeline for completion, and as I said, this is already in the making. But we don't want to communicate a specific target in terms of time, also because that would make it inflexible for us. We could choose to change the timing depending on the dialogues we have in commercial side. So we don't really want to specify that yet, but we will update, of course, as soon as it's relevant.
Okay. And then if we go perhaps into the licensing deals and partnership deals that you are targeting in the future and the one that you have done in the past, what is the biggest obstacle to form a partnership where you can actually sell the product as a license? And what is the biggest reason that it has not happened so far?
I think it's fair to say that it has been rather evident that the industry has been kind of skeptical towards our technology, at least parts of the industry, because we introduce a completely new way of controlling a display and driving a display, but also mainly driving the direction from an image. As I said, all current 3D glasses-free displays are lenticular based, so this is kind of a totally new approach. And as we challenge the established display architecture made by huge companies and already running in mass production, there is a steep sort of acceptance curve to happen. And again, many of those companies are giants. Samsung and LG, and we're not talking to the top management at those companies because there are so many layers. We're getting closer. But even the mastodons there say that we need to adapt. We need to change because the world is rapidly changing, and we heard this from one of the giants there. We may not be here 10 years from now if we don't adapt from being a fast follower to becoming an innovative leader. And in order to do that, we know that we need to change our ways, and we need to take the leadership and be aggressive in the investment and in the innovation. So then you can ask yourself, why is it so difficult for us to get started with those guys? And and I think there is also there are different reasons. One is also cultural. We come from the Nordic, claiming to have the answer for the future 3D display, while let's face it, the display industry is in Asia, and they are very proud people and established in their thinking that displays are made and innovated and manufactured in Asia. So why should they believe a bunch of Danes and Swedes and okay, Taiwanese as well? But so that's a big part of it as well. They're skeptical, but they are seeing more and more proof from our side. It has taken longer time than we hoped, but the PlayNitride step was important and a big positive step for us because we then demonstrated to the industry we can partner up with a display company and make this work. Then, yeah, again, the balance is how much do we have to prove, and this is where I think it becomes sort of sometimes frustrating because we know that this would happen a lot faster if we did the implementations or the iterations together with the LGs, the Samsungs, the whatever, the larger corporations, instead of having to do it ourselves or with Goworld. So why are they not jumping on the boat and helping us do this faster? That's the big question. Whether or not it's down to yeah, I don't know. We have added to the team in Taiwan also some capabilities on the commercial side, because the display industry, as I said, is in Asia, and it's sometimes difficult for us being too far away and being, culturally and language barrier-wise being maybe too far from each other. So we have added resources on that business side as well. So we are now a lot closer, speaking their own language, also on the commercial side, not only on the engineering side. And I'm truly hoping that will help speed things up also in the future.
Are there ongoing discussions and dialogues today where the technology fully meets customer requirements, but where the agreement terms are the primary obstacle to finalize it?
part of the iteration, as I said, is expanding the features we can enable. So for many customers going into this, it's of course important that they're not just sort of left on the station with only sort of the first feature set, and then they're overtaken by another competitor doing a better DPT product. So part of the negotiations is also being among the first customers. How much right do you have? How much sort of first mover benefit do you expect, and can we give? So those are all parts of a rather complex negotiation. IP is always a big part of it. We are very stubborn in terms of insisting on maintaining a free position in terms of IP in our core IP. This is important, of course, because we don't want to get stuck with only one or two customers. We want DPT to be a broad technology available for many. But it's always a big battle because company laying on a lot of money on the table are, of course, also wanting to have some freedom to operate in the beginning or some head start and all that. So yeah, not always easy.
No. We have a question regarding the LED wall provider that you have announced to the market. It reads, one LED wall provider is in the process of securing a budget and a timeline for a mass production product. Does this mean that they are planning a mass production product including DPT, and that they already have come to the conclusion that DPT has potential as included in a mass production product? Is this including existing SLM or the coming version?
So the LED wall provider has the ambition of mass producing an LED wall with capabilities that our SLM provide, for sure. Of course, all R&D processes have a risk of not meeting the full objectives or resulting in changes, and so that always have to be stated. But there is a clear objective of enabling 3D LED walls. We have not yet signed any contract, but we are in active discussions, and both the current and future versions of the SLM is or are relevant for this specific project.
Okay. Jumping a bit to the PlayNitride collaboration. The collaboration is on the micro LED technology. You say that it's a very promising technology, and I think I heard you say that in the presentation, but it's not mainstream now. But PlayNitride already has developed and are selling micro LED displays. Isn't this a sign that it is indeed mainstream, or how would you look at that?
We certainly see micro LED becoming more and more mainstream. It's becoming a growing, or it's growing its market share little by little. I have no doubt in my mind that micro LED will become a huge technology, meaning they will take eventually a big chunk of the market share in terms of display technologies. But we also have to acknowledge that it's still early days for micro LED. In quite a few years, OLED has been talk of the town as the high-end display technology with a lot of benefits. It's flexible, you can roll it, can be almost transparent. It has very black level, and all those things are true. Still, OLED has, I think, below 10% market share. If you see overall, in some areas, of course, they have a larger market share. If you look at high-end TVs or the latest EVs, for example. But overall, in terms of units sold, it's still a rather small market share, and that's been a lot of years coming. So all we're saying is that micro LED is even younger in terms of display technology, but with a lot of promising specs on their side. I mean, micro LED can eventually be cheaper to manufacture. I think no doubt about that. They're not there yet, but as they become cheaper to manufacture, it's going to explode. They can be flexible, bendable. They have a lot longer lifetime than OLED, for example. OLED is hindered maybe also because there's only a handful of companies that are capable of manufacturing OLED displays. So it's a very sort of controlled technology. It's very, it's not very democratic. They control the pricing, they control the scaling, the available sizes, etc. On micro LED, it's a different topic because there are so many companies out there capable of producing LED displays today. We see that with if you look at the big wall LED displays and the pricing, that have come down drastically over the last just 5 years. The pricing has significantly decreased on the large LED wall segment. That's because a lot of companies are now able to manufacture LED. And the same will become true on the micro LED side. There are already a long list of companies manufacturing micro LED in the early days, and so many companies competing will typically also tend to lead to better and cheaper products in the end. Therefore, we think that micro LED will eventually have a huge market share. So that's all we're saying when we refer to it as maybe a coming important. We certainly don't want to degrade micro LED as a current product, because there are micro LED products out there, and we are big fans of micro LED. Just saying that the market share still small, but will increase drastically in not too many years. I think huge companies like Samsung and AUO, BOE, are betting big time on micro LED. So of course it will happen.
Great, thank you. We have another question being posted recently here. Could you please describe the Samsung event? And I believe the reference is to a Samsung event that happened early in the summer where you participated, and your expectations and hopes from that event.
We were invited by Samsung Display Research Division to present our technology, and this is one of the examples of us coming closer to the top management, because this is the department in Samsung Display that are making the future panels of the displays. And they have been following our every move for quite a while. It turned out they have been reading all articles, all white papers, all patent applications that are becoming public. So they had a huge knowledge of what we were doing. And they were very impressed to see the progress we've made, specifically with the PlayNitride demonstrations. So what we're discussing with them is and this is an example of what I said earlier. They are one of the ones that they need to take a choice at a certain time, because they are also dipping their toes into the 3D display market currently, using a layer technology on the single user displays. But they know that the big push will come once they find the correct technology for the multi-user scenarios. And they are seeing a lot of potential in DPT. But as one of the manufacturers there, they're eagerly awaiting us to prove the fact that we can do multi-user, look around, enable the full set of features on the DPT. This is an active dialogue with them. And what I'm trying to do, of course, is to get them to step on as soon as possible to speed up the development. Again, as I talked about earlier, instead of just sitting there and waiting for us to do it in the slow way. But that's the back and forth. We were then also participating on another big event where we were invited to showcase our technology. We did so. We got a very prominent location among companies invited. We were actually positioned as the first one. So maybe that's a sign, at least we were told that they had a lot of interest in our technology. But we're not allowed to say what's going on at the moment or much more about that event, actually. So, but a great experience and a positive one as well.
And another one coming in here. According to both the prospectus and the Q2 report, you anticipate NRE, non-recurring engineering revenue, in 2025 and 2026, and volume-based licensing revenue starting late 2026 or early 2027. Is it correct to interpret that the expected license income from a customer would first be preceded by NRE revenue due to required modifications, integration, or work or similar? So any licensing deal would be preceded by an NRE collaboration, I assume.
Yeah, that's typically how it goes. Is you start with an NRE phase where we adapt our technology to the specific product need and the specific list of features and size, resolution, etc., design. And then when the product hopefully then go into mass production, then the licensing, per unit licensing will kick in. Sometimes you can get lucky and negotiate an upfront license payment, meaning a sort of pre-agreed prepayment of licenses, or if you will, or a success-based fee or something like that. Or as I said, if we agree on certain benefits for being the first in a certain segment or something else, then that can come with the price. So the customer has to pay more for say a small grace period of being the only one in a certain segment or something like that. So that can also occur. But yeah, typically a project starts with an NRE phase with some payments for that development phase, then hopefully followed by a mass manufacturing with per unit licensing.
Okay. Also, as a follow-on to that question, stating that you also say in the Q2 report that you still target NRE and upfront payments from multiple customer projects in 2025 and 2026. If you should receive deals in 2025, as you say, it seems like the existing version of the SLM is good enough for deals, or that potential customers trust you in developing the new one. So would that be a fair conclusion?
Exactly.
Yeah.
Fair conclusion.
Good. We are about a meeting or an hour into the meeting, and if someone is pressed for time, of course, feel free to leave the meeting. We will try to answer perhaps not all the questions because there are a lot left, but I will try to sort out the ones that I believe are most interesting. If you don't mind, here's another one. You did form a partnership with Goworld, and you mentioned that they are still developing it, even though it seemed really good as it was at the end of December 2023. Is there still more development needed before this can be sold? I assume the first version of the SLM would be sufficient here.
That's a good question. What we showed in the end of 23 and also at CES in the beginning of 24 publicly was a demonstration of some of our features, but based on non-manufacturable, or at least not on a reasonable price level, manufacturable design or component set. And we also tried to explain that as good as we could, because that was the first demonstration of what our principle brings to a display. But in order to prove that or show that as fast as possible, we showed it by the use of components that are not capable of being manufactured at a reasonable price and at a reasonable image or display thickness. We also showed a 3D display, which was very bulky, very thick, and no panel maker wants to really do, at least not consumer product-wise, would want to launch a bulky product. So we were also saying at the time that this is a demonstration of the technology capability, but not the actual components. And those would have to be manufactured. At this time, we said together with the customers, because we were anticipating that we could get some customers on board and pay for the iteration of the core technology. That was a bit of a disappointment for us, because many of them said, "Hey, this is super interesting. Please show us your next iteration," basically, sort of summing it up, right? And we tried negotiating and tried to get different companies on board to pay for this iteration. But it took so long that in the end, we decided to go another route and find a partner. We found Goworld, do a partnership, get their expertise and resources on board, so we don't have to stand with the whole bill ourselves. But that took a detour before we could then, about a year later, show the SLM, the first version of the SLM. And the SLM design is certainly well enough to create a product which is slim, high resolution, but depending on the underlying display technology, the size, and the display resolution, there will always be sort of an NRE phase, as I said, where we have to adapt and design an SLM to that specific product. Moreover, we are spending the time while we on the engineer side, while we are doing the negotiations, we are spending time on the engineer side, since it's Goworld doing most of the work, to do the iteration where we onboard even more feature sets by onboarding or incorporating the faster crystal, the FLC, because that will speed up everything for us business-wise as well. So yes, we have made DPT technology productional or production friendly and enabled mass production with the first SLM. We are now expanding capabilities and the feature set and adapting to the display behind it.
For the sake of saving time, there's a question regarding your collaboration with Amtran, but I think that was answered during the presentation. And perhaps going into the transaction as such, how much will Claes and Peter, i.e. the founders, and Amtran and Belser, which is also one of the larger shareholders, subscribe for in the current rights issue?
Yeah, so of course, there's been a lot of reactions and questions regarding the issue. We tried doing something different in the beginning. So we had quite a lot of interest going for us around the time where we launched the PlayNitride display demo. And we had expected to be able to do a different setup with industry partners. We were quite a long way in those negotiations. Then at the time, Mr. Trump started shaking the industry with the tariff situation. A lot of insecurity was spreading among the display companies out there, and that's one of the reasons we got why those conversations started lacking, and we needed to do something else. At the time, we then spoke to Belser and Amtran about pre-commitments. At that time, they were not willing to pre-commit for certain reasons. So that has been tried and turned down. How they will act in this subscription period, of course, we don't know. we cannot say and promise. Peter and I are unfortunately not able to really participate to any big extents. We are fully committed and invested. We don't have extra capital lying around. This is our full focus. Anything we do is invested already here. So I hope that answers the questions.
Yes, it does. Continuing on the transaction, it is secured to a level of 60%. So about 30 million of the 50 in gross proceeds have been secured through guarantee undertakings. Will this be, or how far will this take you, I guess is the question.
There's no question that the higher subscription rate we can get, the further we can go, the higher the chance is that we break through the barrier of becoming in full revenue. But we estimate that even with the 60%, that there is a chance, of course, given the underlying circumstances, that we could reach break even. There are, as we have said, a lot of positive dialogues ongoing now. Not promising anything, but a lot of good things can happen within the next 12 months. And even with the 60%, we have a chance of fulfilling those.
Thanks, Claes. And before I let you and Torben go, I think I will just round off, since everyone is very interested in potential future agreements. And I know, of course, that you cannot really promise anything or comment future events, but I think this will be the last one for today. Do you feel confident that your ongoing discussions will result in concrete agreements, or do you see a need to engage new potential clients? If so, what strategies do you use to reach them? And I think we should keep in mind that you have guided for NRE revenue or new agreements in 25 or 26.
Yes, we feel confident in some of the current projects and conversations becoming real projects. So of course we have constantly activities ongoing to onboard new ones, but we are currently focusing on the ones we have.
Okay.
And I'm sorry, Torben, I took all the answers. Yeah.
No worries, Claes.
Thanks to both of you for joining us this afternoon. If there are additional questions regarding the transaction or regarding the company, please don't hesitate to contact either us at Västra Hamnen or directly to the company, to Claes and Torben, and we will do our best to answer those questions also. Many thanks. Bye.
Thank you.
Thanks.